Hi, everybody. My name is Mitchell. I'm a Simcenter 3D application engineer. So our agenda is going to be pretty straightforward today. We're going to be going through the introduction. We'll talk about geometry cleanup, and then we'll go through some meshing fundamentals. Then we'll talk about 0 to 3D meshing, and we'll end with a cantilever comparison between different meshing techniques. So why are we talking about this? Why does mesh optimization matter? So of course, having poor geometry leads to failed solves, low accuracy, and distorted elements. If you have highly complicated parts and you aren't using the tools that Simcenter 3D offers you, you're making it a lot harder on the program and on yourself. On the other hand, if you have too many elements and nodes, this will lead to extremely long solve times, high memory usage, and software crashes. So the goal is clean geometry and smart meshing, leading to faster solve time, low memory use, stable solutions, and high accuracy. So how do we get there? It starts with geometry cleanup. This is done in the Idealize part to start with. If you don't know what the Idealize part is, it's linked to the master model. So any changes we make here will be local to the part, but the original geometry is based off of our original part. You can remove features, split bodies, create mid-surfaces, and modify dimensions. So if we just pop over to Simcenter here, I just created a part that's not really representing anything. It's just got some curves, it's got some fillets, it's got some holes. You can see there's different steps here. So what we're going to do is we are going to create our idealized part. Of course, the first thing you have to do is promote a body anytime you're editing this in the idealized part. And we're just going to show some tools that could really help you when modifying geometry. So if you want to get rid of these holes, you're able to do so with delete face. You can find loose matches, exact matches. But there are other options to choose from. If you have experience with NX, you'll know that there's about 1 million different routes that'll take you to the same result. And it's the same way with Simcenter. So you can also use deep feature geometry. This works with holes. This works with fillets. This works with some other geometry. You can play around with this if you want. But these commands, they have the same function to some degree, but a lot of them are a little more specialized. So if you're having trouble working a command, you can always try a different one because I guarantee you there's another route to take when you're trying to get to a certain result. And another one that I want to showcase is idealized geometry, where we're able to take an entire body and get rid of all the holes and blends under a certain radius or diameter at once, which is really nice and really fast if you want to get rid of a bunch of mounting holes off of a plate that you really do not need for meshing. And if you want to go back and you say, okay, actually we don't want to do that, all of these changes create features in the part navigator, so you can always go and delete them if you want. And another thing that I want to showcase is move face. You can see we can grab one of these faces and it'll grab that face next to it as it meets it. And so if you don't want to do that, there's also the option to use pull face. So again, just going to show you that some of these commands have overlapping responsibilities, but they don't work exactly the same. So again, if I were you, I would just play around with these commands just once or twice each, just so that you get a feel for them. And if you're, in the future, you're thinking to yourself, oh, I wish I could do this, I can almost guarantee that you're able to do it. You just need to know where to look. So we are going to mid-surface this and create a shell for a later part of our demo. So the second part of geometry cleanup is called abstraction. It's in the FEM file. Now, Simcenter 3D automatically abstracts a little bit. You can see here it gets rid of that sliver surface in the top right. It just does that by meshing. But if you want to manually edit the mesh, or manually edit the geometry before you mesh, you're able to do so. So we're going to take this part into our FEM file. And there's a bunch of options here in this polygon geometry section. And like I said earlier, with the Idealize part, I would just go ahead and play with all these tools at least once or twice, just so that you know that they're there and that they exist. So I'm just going to showcase a few that I think are neat, like auto heal geometry, which is kind of like our Idealize geometry command from the last part. We're able to take a face or an object here and get rid of all the small features or holes under a certain size. And what's nice about doing this instead of the idealized part is that when we get rid of these holes, it'll create mesh points, which we can add loads and constraints to, and the elements will form around. Another one that you can use instead is suppress hole. Like I said, a lot of these commands have overlapping responsibilities, but they do work slightly differently. So if you just want to take this one hole at a time, you're able to do so with suppress hole. If you want to fill in a gap that you have in a part here and it's kind of an irregular hole, you're able to do so with face from boundary edges. And then if you want your mesh to have a smooth mesh over this area and not have to form elements around this edge, you're able to merge these faces. And the last tool I want to show you is freeze geometry, which is really nice if you want to make sure that a face does not get touched during the meshing, or you don't accidentally edit it during any of the abstraction. And then also auto heat or reset, which will undo the changes that you've made during this abstraction. So moving on to mesh fundamentals. 0D elements are lumped or distributed masses. 1D elements are beams, rods, bars, pipes, anything like that. 2D elements are mainly for thin-walled parts, but you can use it on any face. And then 3D elements are your standard, meshing for 3D objects or complicated geometry. Another thing that I want to point out about meshes real quick is that you can use mesh controls to spot reduce or increase the number of elements and nodes on a face or an edge. And it's really just a great way to change your mesh one area at a time if need be. So moving on to 0D meshing. This is a point mass. It adds weight, inertia, and mass, but it does not represent real geometry. So I'll show you what this looks like. You can see here we have a carrier drone. It's carrying this pizza box. And instead of having to worry about how are we going to mesh this pizza box, what we can do is we can just create a point in the center of this. Now there's an option when you create a 0D mesh to just use the center of gravity of a part. But since we don't have a material assigned to this pizza box because it's a pizza, we can just create one in the middle manually. So what we're going to do is we're going to create a 0D mesh at that point. Then all we have to do is go into our mesh associated data and choose the mass that we want. So we'll say 1.5 kilograms, maybe a little bit heavy, but we'll just overshoot. So you can see it's created that mass point in the middle here because we want to simulate this drone carrying it. And the way that we're going to connect it is by using our 1D connection point to face command over here. So we're just going to connect it to all the faces that are going to be carrying this box. Once we do so, it'll show you what that looks like visually. And then we're just going to throw on a 3D tetrahedral mesh on this real quick just to show you what this connection is going to look like. You can see here when we create this, there's going to be a lot of nodes. So if we want to reduce the amount of nodes per face here, because we don't need that much for the connection, like I said earlier, mesh control is a really great way to spot, reduce, or increase the size of a mesh, and the coarseness of a mesh, one face at a time or one edge at a time. So we can let it choose for us a better element size specifically tailored for these faces. After it does so, you're going to see that it's drastically reduced the amount of nodes per face here. And there's plenty of other things that we can do to customize this, but that was just an example of using mesh controls. So moving on to 1D meshing. Like I said earlier, this is for beams, bars, rods, and anything similar. You can specify the exact number of elements if you want. It's very computationally efficient, and it's great for bending, tension, and shear forces. The drawbacks are that nodes are really only in the center line, and it can oversimplify complex loads. So let's go to our 1D part here. So if you already have a part that you've created and you don't want to have to start from square one for the 1D mesh, what you can do instead is this is an option. We have this connection of tubes here. Of course, we have to promote our body first. We can use a derived curve to extract the center line of all of these tubes at once. You can see what that looks like real quick. So we're going to create our fem file. And of course, when you're 1D meshing, this is all based off of geometry curves. So you want to make sure that you get all of your sketch curves in here when you create the fem file. And then we're going to hide this real quick just so that we can select all these curves for the 1D mesh. And then a cool option that I want to show you when creating these 1D meshes is that, again, if you've already created the CAD geometry for this, you can use that to your advantage by using a P-beam physical property type. You get access to the face of solid beam section option. So you're able to take an existing face instead of having to manually create the dimensions for it and having to worry about entering all the numbers correctly. You can just take an existing face and it'll use that to mesh our 1D beam. And then if we want to make sure that we did this correctly, we can always just display the solid section of it. You can see here it's created a 1D version of our beam. And that's just a really neat option that you might not be aware of. So for 2D meshing, this is for mid-surfacing, as I said earlier. It's perfect for thin-walled parts. It's got a much lower node count than 3D tetrahedral. It's not really made for extremely complex geometry, especially 3D, and it's not suitable for thick parts. So let's go back to that part that we were working on earlier. Now, it probably would be better to mesh all of these faces separately, but if you didn't want to do so for whatever reason, remember this part has different steps of height. So when you create a 2D mesh, you define the thickness in the mesh collector by default. So you go to your mesh collector, you go to your physical properties, and this is where you select your thickness. If you don't want to do that and you want to base it off of the original part, you're able to do so by going to mesh associated data and turning the thickness source to our mid surface rather than the physical property table. So this is just a nice option that you might not be aware of. And another couple things that I want to point out are that you can see here where I have gotten rid of the fillet, the elements are much larger. And where there is still one of those sharp curves, and not even extremely sharp curves, the elements have gotten much smaller. And you can see where there is still a hole, the elements get much smaller because they want to make sure that they're getting accurate readings around those small, tight curves. So again, if your holes are not necessary for the structural integrity of the part, and it will not change your readings, then I highly suggest that you do your best to minimize them. So on to 3D meshing. There's two main options that you have: your 3D tetrahedral mesh that everyone's familiar with, and then your 3D swept mesh. So tetrahedral is great for bodies with any complexity. It's great. It has a lot of customization choices, and it's great for complex stress distribution. The drawbacks are that it has the highest node count by far, and it can definitely be less accurate if it's not created properly. So let's pull up this part here that we have. So I have a couple options here. If I want to, I could just create the FEM file and just throw on a 3D tetrahedral mesh and let it select it for me and just call it a day here, right? While we're in this, I do want to point out the volume mesh settings. Especially if you're dealing with incredibly thick parts and you're not really interested on what's happening in the center of those thick parts, you can change this internal mesh gradation so that there's less elements on the inside, just so that you're not wasting extremely high node counts on stuff that you really aren't looking for. So like I said earlier, we can just throw on a 3D tetrahedral if we want to and call it a day. And it's not a terrible mesh, but it's not perfect, right? It's kind of just thrown about and it fits the part, but it's not going to be as accurate as we could make it. So get rid of that. If we go back to our Idealize part and we put some thought into creating this mesh, what we can do is we can use our split body command and split this at these hinges. And you can see in the settings here, we can have it check for a sweepable body and set the body color. And when it does that, it's created two different sets of colors. Now we can go back to our FEM file. And then I'm going to also merge this face at this edge just so that we don't have really tight elements there. And then I can go ahead and use our 3D swept mesh instead of using our tet mesh to mesh this body. And you can immediately tell that these new meshes are much more tailored to this part rather than that 3D tetrahedral mesh. So as you can see, the mesh is a lot more tailored to this part, and you'll get much better readings. You might have a higher node count, and that's just a trade-off that you have to be willing to make sometimes if you want more accurate readings. It's not necessary 100% of the time, but I'm just here to show you that you have options. So I want to finish this out with a cantilever comparison that I did. This is just a very basic cantilever problem, and I used a 1D beam, a 2D mesh, and a 3D tet mesh to do it. And you can see the node counts. 1D beam had the lowest node count by far, and it had the greatest results. This is because the beam element types are specifically tailored for this bending behavior. It was created specifically for this. So really be aware of your options when you're meshing and make sure that you're getting the most out of what this program offers. So, the main takeaway is element choice matters. Siemens has a really nice element choice, a really nice element handbook that you can look at. And, it goes over all the element types, and, it's a little confusing, but, a lot of elements were made for specific things. So you want to be aware of your options. Again, more elements does not necessarily equal more accuracy, as we saw in that cantilever comparison. And like I said, be aware of your options. You're not going to use a lot of these commands most of the time. You might not use them ever, but there is a chance that you're going to be stuck one day and you're not going to know what to do. But then in the back of your mind, you're going to remember that you use this command one time and it'll save you. So, just be aware of what Simcenter 3D can offer you. All right, on to questions.
Awesome. Thank you so much for walking us through all that. We have two quick questions. Can elements of all types be used together in a solution?
Yeah, you can use 0 to 3D element types all together. You just have to be aware that you're creating the right connections with 1D connections or other commands. So just be careful and make sure, and always double check with your math.
Awesome. And then one last question. What else can be done regarding slow solve times, even if your mesh is efficient?
So there's several things that you can do. Just a couple that come to mind are you can increase the amount of memory dedicated to a solve. You can enable parallel processing, and you can solve only for the outputs that you need. But always double check everything.
Awesome. Well, thank you so much. And thank you everyone for joining us today. As the year comes to a close, we want to thank you for being a part of our sessions this year. We're grateful for your engagement and trust that you place in us as a partner of yours. And we look forward to working with you in the coming years. This session, along with many others, will be available on our YouTube channel. So go hop over there and subscribe to Saratech to discover more of our content. And then if you do have any other questions or comments, you can include them in the survey right after this, or email us at marketing@saratech.com. So we appreciate you guys being here. Have a great day, and we hope you guys all have restful and enjoyable holidays.
Thanks.